Hello friends, today we'll discuss the blood. All living cells have to be provided with nutrients, oxygen and other essential substances to produce energy. Also the waste or harmful substances provided such as urea, uric acid and carbon dioxide have to be removed continuously for healthy functioning of tissues. Hence, there is continuous supply of nutrients and removing of waste from the cells. Simple organisms like sponges and coelenteраtes circulate water from their surroundings through their body cavities to facilitate cells to exchange these substances. And many complex organisms use a special fluid such as blood, interstitial fluid, and lymphs within their bodies to transport such materials. So this is the blood. Blood is the most commonly used body fluid by most of higher organisms including humans for this purpose. Okay. So blood is a special connective tissue consisting of 55% of plasma and approx 45% of formed elements called blood cells. Plasma is a straw-colored viscous fluid consists of 90 to 92% water, 6 to 8% protein, 1.2% nutrients and gases, and 0.8% inorganic salts. The major proteins of the plasma includes albumins, globulins, and fibrinogens. So three proteins. Albumins help in osmotic balance, and globulins help in defense mechanism of the body, and fibrinogen are needed for clotting or coagulation of blood. Plasma also contains a small amount of organic substances like glucose, amino acid, lipid or fat, and respiratory gases such as oxygen and carbon dioxide, and inactive clotting factors also. There is also a small amount of organic salts such as sodium, calcium, magnesium, and bicarbonate. So blood, approx 45% of the formed elements. Blood includes erythrocytes, leukocytes, and platelets. Erythrocytes or RBC, red blood cells, consist of approx 99% of all the cells in the blood. RBC are formed in the red bone marrow in adults. A healthy adult man has an average 5 million to 5.5 millions of RBC per cubic liter blood. RBC consist of hemoglobin. They have a red colored iron containing complex protein called hemoglobins, hence the color and names of these cells. These molecules play a significant role in transport of respiratory gases. RBCs have an average lifespan of 120 days, after which they are destroyed in a spleen, that is also called graveyard of RBC. RBC, due to less count of RBC, there may be anemic. So now white blood cell, also called leukocytes. Leukocytes or white blood cells are colorless and nucleated, but RBC non-nucleated. The white blood cells are relatively lesser in number, which averages 6,000 to 8,000 per cubic of blood. Leukocytes are generally short-lived. We have two main categories, granulocytes and agranulocytes, based on the presence of cytoplasmic granules. So this granulocytes consist of neutrophils 60 to 65%, eosinophils 3%, basophils 0.5 to 1%, and this agranulocytes consist of lymphocytes and monocytes. Now Neutrophils and monocytes, 6 to 8%, are phagocytic cells which destroy foreign organisms entering the body. So eosinophil, 2.2 to 3%, resist infection and are also associated with allergic reactions. And basophils secretes histamines, serotonin, heparin, extras, and are involved in inflammatory reaction. Lymphocytes, 20 to 25%, are of two major types, B and T forms. Both B and T lymphocytes are responsible for immune response of the body. So T lymphocytes attacks tumor cells and B lymphocytes produce antibodies. This WC 4000 to 11,000 cells per cubic millimeter. So blood consists of 45, and this platelets also. Platelets are called thrombocytes, are cell fragments produced from megakaryocytes, special cells in the bone marrow. Blood normally contains 1.5 lakh to 3.5 lakh platelets per cubic meter. Platelets can release a variety of substances, most of which are involved in the coagulation or clotting of blood. A reduction in their number can lead to clotting disorder, which will lead to excessive loss of blood from the body. Coagulation or clotting of blood in response to an injury or trauma is a mechanism to prevent excessive loss of blood from the body. A dark reddish-brown scum formed at the site of a cut or an injury over a period of time. It is a clot or coagulation formed mainly of a network of threads called fibrins, in which dead and damaged formed elements of blood are trapped. Fibrins are formed by the conversion of inactive fibrinogens in the plasma by the enzyme thrombin. Thrombins in turn are formed from the another inactive substances present in the plasma called prothrombin. An enzyme complex thrombokinase is required for the above reaction. This complex is formed by a series of linked enzyme reactions called cascade process, involving a number of factors present in the plasma in an inactive state. So an injury or a trauma stimulates the platelets in the blood to release certain factors which activate the mechanism of coagulations. Calcium ions play a very important role in clotting. Plasma without clotting factors is called serum. So now lymphs or tissue fluids. Apart from blood, interstitial fluid or tissue fluids and lymphs also help in the transport of certain substances. Interstitial fluid or tissue fluid has the same minerals distribution as that in the plasma. So exchange of nutrients, gas, etc. between the blood and the cells always occur through the interstitial fluid or tissue fluids. An elaborate network of vessels called the lymphatic systems collects this fluid and drains it back to the major veins. The fluid present in the lymphatic system is called lymph. Lymph is a colorless fluid containing specialized lymphocytes which are responsible for the immune responses of the body. Lymph is also an important carrier for nutrients, hormones, etc. Fats are absorbed through lymph in the lacteals present in the interstitial villi. Now blood group. Blood group It is introduced by Karl Landsteiner, who categorized the blood group into the ABO group and RH group. Two types. IBO group and RH groups are widely used all over the world. This is characterized by Karl Landsteiner. ABO group grouping is based on the presence or absence of two surface antigens on the RBC, namely A and B. And RH grouping is based on the presence of or absence of RH antigen present on the surface of RBC, similar to one present in the rhesus monkey. It was first in rhesus monkey. Different blood groups according to ABO blood groups are A, B, AB and O blood group. The plasma of different individuals contain two natural antibodies or protein produced in response to antigens. The distribution of antigen antibodies in four group of blood A, B, AB and O are as following in this table. You can see this is the different types of blood groups A, B, AB and O. These have A has A antigen and antibody B, and AB has antigen AB and no antibody, and blood group O has no antigen and anti-A and anti-B antibodies. So this is the grouping of ABO systems. From the above mentioned table, it is evident that the group O blood can be donated to person with any other blood group, and hence O group individuals are called individual donors. This is the individual donors, O group. Persons with AB groups can accept blood from various persons with AB as well as other groups of bloods. Therefore, such persons are called universal recipients. So, two types of recipient and donor, and this is the universal donor is called blood group O, and universal recipient is blood group this AB. Okay, so the donor's capability is discussed here. You probably know that during blood transfusions, any blood cannot be used. The blood of a donor has to be carefully matched with the blood of a recipient before any blood transfusion to avoid any severe problem of clumping, that is destruction of RBC. So matching is very important before transfusion of bloods. So this is showing blood group O may be given to O, A, B or AB. Blood group A only 2. And now this is the universal donor. Blood group O may be given to AB and AB and O both. So may be given to all types of blood group. And this is about the AB blood grouping. Now we will discuss the RH blood grouping. So this is the another antigen, the RH antigen, similar to one present in rhesus monkey, is also observed on the surface of RBC of majority, nearly 80% of the humans are RH positives. And this is a special case of RH incompatibility or mismatchings has been observed between the RH negative blood of a pregnant mother with the RH positive blood of the fetus. RH antigen of the fetus do not get exposed to the RH negative blood of the mother in the first pregnancy, as the two blood are well separated by the placenta. So, however, during the delivery of the first child, there is a possibility of exposure of the maternal blood to a small amount of Rh positive blood from the fetus. In such cases, the mother starts preparing antibodies against the Rh antigen in her blood. In case of her subsequent pregnancy, the Rh antibodies from the mother can leak into the blood of the fetus and destroy the fetal RBC. This could be fatal to the fetus or could cause severe anemic jaundice or the baby. This condition is called erythroblastosis foetis. This can be avoided by the administering anti-Rh antibodies to the mothers immediately after delivery of the first child. So, antibodies, this anti-Rh antibody is essential. Okay, thank you. Next class we will discuss the circulatory systems.